So the Kitimat project is comprised of a number of pieces. First of all, there's the large upstream resource in northeast BC, the Horn River and Liard basins. We're then going to connect that gas through a pipeline that we'll construct called the Pacific Trail Pipeline. The site at Bish Cove, we're going to build a 2-train LNG project, and we're going to be capable of exporting over 10 million tons of LNG per year.
So my responsibility is to deliver a 42-inch natural gas pipeline from Summit Lake all the way to Bish Cove. And we will be crossing over the coastal mountain range. Our goal is to maximize benefits for the communities, but minimize the impact by offering opportunities with employment, training, and contracts. So to build a pipeline, we need to survey and identify the right-of-way. And once we go through all of our environmental permitting and engagements with First Nations stakeholders, partners, and local communities, we then are better prepared to clear the right-of-way. The Pacific Trail Pipeline will have a construction right-of-way of about 38 meters. We build roads to access the right-of-way. Then we're ready to start the mainline construction. Mainline construction is highly specialized, and they will do the bulk of the pipeline construction work. And then testing it at the end to ensure that it has integrity before we put the pipeline in service. In general, we will be revegetating the whole area. And when we're done, the right-of-way that we're going to maintain, it will be about 18 meters.
As part of our environmental plan, PTP will be employing the best available practices for watercourse crossings. All our watercourses are generally constructed by a separate crew that are trained in going through watercourses. In the 480 some odd kilometers we have to pipeline through, we've encountered in the order of 1,000 watercourses, most of which are what we call drains. And basically they're flowing water only during the spring runoff. So when they come up to a dry watercourse, if there's specific habitat, for instance bush or anything like that, that needs to be salvaged, we salvage it. Once they've got the top layer off, then they dig the ditch. Then they put the pipeline in and it's backfilled, and then the top layer is reestablished and the contours are put back in place. Once they've done their job, then there's a restoration crew that comes in and they either reseed it with approved seed or they do some other enhancements to the watercourse. The bulk of our watercourse crossings will have water in them and may or may not have fish. And they'll range from 1 meter to probably 4 meters wide. Before we even touch the watercourse, we've studied it to determine if there's fish there, what kinds of fish, what's the best time to cross that stream, so that we minimize the impact. So what we want to do is make sure that when we excavate, we're not digging through the water, because again, we would add sediment to the watercourse. If there's fish in it, we get the fish out of there by electrofishing or by netting them. And then we take the water out of the isolated area and pump it downstream, so it's clean water going downstream. And then once the watercourse is dry, we send in our excavators. And they excavate the top layer of the bed and banks and store that separately. They then dig the trench, and the pipe is then put in the trench, it's backfilled, and then we put the top layer back on. Our plan is to get in there early in the morning, complete our watercourse crossing by the end of the day. We have 13 watercourse crossings that are large, and in order to cross them in the best practice, we've chosen to use what we call trenchless techniques, a bridge or an aerial crossing. The trenchless techniques this common term of horizontal directionally drilled. Our directional drills are anywhere from 600 meters to a little over 1,000. And they could take us almost 2 months to complete. When we undertake a directional drill, we're roughly 200 meters on either side of the watercourse, the minimum. We have the pipe that's going to go in the hole already welded up and tested. The drilling rig then sets up at the entry point, drills underneath the watercourse by a minimum of 8 meters below its lowest point, and comes out the other side. Once it's got the hole done, the rig attaches to the pipe and pulls the pipe into the hole towards the entry point. Once that's done, rig is pulled out of the way and we weld the section to the pipe that's on the ground. And then it's retested, so it's actually tested twice underneath the water. And we have about 3 or 4 bridge crossings. You have a clear span bridge over top of the watercourse. And on that bridge, you have a decking that is used for vehicle access. But on the side of the bridge, you have our pipeline. The third category of major watercourse crossings is an aerial crossing, which pipe is suspended above ground over the watercourse, and the watercourse is not affected at all. No matter what crossing technique we use, we're trying to minimize the impact on the water and the fish and other aquatic habitat.
We are committed to the highest possible standards because this pipeline will be in operation for a minimum of 40 years.
About 90% of the people out here are local. And they know it's their backyard too. When you get out to them and explain the environmental regulations and what we're supposed to be doing here, they understand what's really at stake here.